I want to go through the steps to solve a linear equation in one variable. So first I will turn on my pen, and then I will start. So steps to solve a linear equation in one variable. Okay, I'm going to start with step 0. That's because this first step is optional, even if it's possible to do. Now, sometimes you won't have to do some of these steps or other of these steps. You never have to do this first one, but you can. So if you have fractions, it's really when you'd use this. You can multiply both sides of the equation by the least common denominator of all the fractions on either side of the equation. If you have fractions and you do not want to deal with them, this is a choice you can make. Multiply both sides, get rid of all the fractions by multiplying by the least common multiple or least common denominator of all the fractions. Be careful when you do this. Make sure you multiply everything by that, each term. And yeah, there's our option. Now, what allows us to do that without changing our solution set, of course, is the multiplication property of equality. So that's an option. Okay, here's step 1. You'll always want to do this, or at least make sure that you couldn't, or that it's already been done. Simplify both sides of the equation. And by that I mean what I always mean when I say to simplify an algebraic expression, because we're dealing with linear equations in one variable, they're going to be algebraic expressions. I want you to combine like terms, use a distributive property to remove parentheses, all that stuff. Get them written as simply as you can. Okay? Step 2. At this point, you should just have some things added or subtracted from each other on both sides of your equation. You might have something times your variable, a number times your variable, but nothing else crazy going on. So our next step is to collect all the variable terms on one side of the equation and all the constant terms on the other. To do that, I'm going to use that addition property of equality, right? Add or subtract things from both sides. Because if I subtract all the variables from or subtract the variable term from one side where it is, it'll end up on the other side, something like that. Okay, use that addition property of equality. Step 3, I'm going to either multiply or divide so that the coefficient on the variable is 1. Okay, right? I'm going to multiply or divide by whatever I need to do so that I just have x equals something, or something equals y, or whatever variable I'm trying to solve for. I want to make it so that I've just got that, because then I can see what the solution is. As a note, a lot of my students mess up at this step because they do it too soon. That was a terrible star or asterisk or something. You can't do this step until you have something like a number times your variable equals another number, or your variable divided by some number equals another number. You have to kind of have one term equals one term before you can do this part, because otherwise you can't divide right or you can't multiply right because you're going to have to multiply by a bunch of stuff and then you might miss something. Don't do this step until you've got one thing over here equals one thing over there. Okay, if you try to do it any sooner than that, you'll probably make a mistake or you could make a mistake and it's not worth it. So don't do that third step until you're sure multiplying or dividing will just leave you with your variable equals something and you just have to multiply or divide that other side by one thing. Finally, if I've made it to this point, I should now have x equals 7 or y equals 32 or negative 12 equals z, or I should be able to see exactly what my solution is to my original equation because I've done these equivalent equation maintaining things to get here. So my last step is to check my solution in the original equation. I want to do this to make sure that I didn't make an algebra or arithmetic mistake, because those are the two types of mistakes that I could make. If the number that I have satisfies my original equation, I can be pretty sure that everything's good, that I found at least a solution. If the number I go back and check does not satisfy my original equation, it does not make it a true statement, then I'm in trouble. I went wrong somewhere, and I'm going to have to either look through my steps and try to figure out where I went wrong, or redo the problem. And that's a bummer, but that's how math goes, right? We can do all this good work and we can do everything right except one little step and get something wrong. And then we don't have the solution to the equation. So telling someone that we do would be wrong. So we need to go back and fix it. All right, I just want to go through two examples using these steps. In any other videos where I solve equations, I probably won't specifically refer to these steps because I'll just be doing stuff. So just be aware of that. If you want to check out these steps and hear me talk about and reference these steps explicitly, this is a video to do it in. All right, so here I am, step 0. I don't have any fractions here, so I'm not going to multiply to get rid of fractions because that won't do me any good. Okay, so then I'm on to step 1, simplify both sides of the equation. This right-hand side, pretty simplified already. It's not going to get better than 45. But on the left side here, I see that I could do some work in order to simplify it. Right, I have parentheses. Whenever I have parentheses with a number or something in front of them, I can use that distributive property. So I'm going to do that. I'll take 9 times 5x and 9 times minus 2. So this will be 45x minus 18 equals 45. Okay, I can't simplify the left side anymore. As we already said, the right side is good, so I'm done with my step 1. I've simplified both sides of this equation as much as I can. Okay, step 2, collect all the variable terms on one side and all the constant terms on the other. Well, I already have all my variable terms together. They are right here. So what I really want to do is deal with this 18. I want him to go away. So I want him to go over to that side of the equation. So how am I going to do that? Well, I've got that additive property of equality, so I'm going to take and add 18 to both sides. Because 45x minus 18 plus 18 will give me just 45x. Okay, take the time during this step to actually simplify, okay? Ignore what you have going on the other side of the screen and just focus, or on the other side of your equal sign, and just focus right here. Make sure that when you take this, your number goes away. If your number that you're trying to move doesn't go away, it doubles instead, you did the wrong thing, okay? So you can go back and change your signs and try again. So 45x minus 18 and then plus 18 will leave me back here at 45x. 45 plus 18 would be 55 plus 8, or 63. Okay, so now I have 45x equals 63. This is exactly what I wanted to do step 3. Right? I have just one thing on this side of the equation, my number times a variable. I have just one thing on this side of the equation, just a number. So I'm all set to use a division property, or multiplication property to divide, rather. So 45x, 63. I want to divide by this 45 because I want to have x equals. If I have x equals, it's easy to see what the solution is. So I'm also going to divide this side by 45. 45 times x divided by 45 is just x. 63 divided by 45, well, let's look at that for a second. That's a fraction. But I can definitely simplify it a little bit. These are both divisible by 3, and even better, they're divisible by 9. 63 divided by 9 is 7. 45 divided by 9 is 5. So I get x is 7/5. Now, you may be asking me, well, can't I write it in a different way? Sure, right? That's a fraction. It has a nice decimal equivalent. 7/5 is also 1 4/10. It's 1 2/5. 1 4/10. Okay, sure, that's fine. It's also 1 2/5, which, if we're doing algebra, makes me a little sad. Okay, I don't like 1 2/5 as an answer to this question, even though it's the right number, just because if I'm going to do other algebra things, I'm going to change it back into a fraction anyway. So, of these three versions of writing 7/5, my first favorite is 7/5. My second favorite, and it's a ways back, but it's fine, is 1 4/10. And then way, 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 way back there is 1 2/5. Don't like 1 2/5. But either way, I've got my solution, right? It's easy to say in each of these instances what the answer is. So I think it's 7/5. So let's see if 7/5 is actually the solution to that equation. So I've got 9. Oops, I'd like black there. I've got 9 times 5 times 7/5 minus 2. And I want to know, is that equal to 45? Is this a true equation? Well, let me see. This is 9 times 7/5 times 5 is 7, which is nice. 7 minus 2 is 5. And I don't need to write down 45 equals 45 because I know that that's true. 9 times 5 is 45, which is 45. So 7/5 is my solution here. Great. Awesome. We got 7/5. That's my solution to that equation. We followed those steps and ended up where we wanted to be just by going through all these equivalent equations. We did all these equivalent equations and found our solution. Let's do one more with these steps here. This time I've got some fractions. So I'm going to do that step 0 where I multiply both sides of the equation by the least common multiple of either side, or of all the fractions on either side. So I see a fraction with a 3, and I see a fraction with a 2, so my least common denominator is going to be 6. You don't have to use the least common denominator. You can use any common denominator. I like the least one just because it keeps the number smaller, makes the arithmetic easier. But here I go with that step 0. I'm going to take 6 times this whole side and say that that equals 6 times this whole side. Okay, notice I multiplied both sides. I just put both sides in parentheses and put that 6 out there to say that I'm multiplying by it. Multiply both sides. Now that I've done that, I proceed like normal. My next step, step number 1, is to simplify both sides. To start to simplify this side of the equation, I'm going to use the distributive property. So this is 6 times 20 is 120. minus 6 times z over 3, so I'll come back for that one, equals 6 times z over 2. Okay, I can simplify more here. So 120 minus, now, 6 times z divided by 3. What if instead I did 6 divided by 3 times z? Can I do that? No, the order of operations doesn't imply that I can. However, I'll end up with the same answer here either way. This should be twice of what z is. If you're not sure why that happened that way, put that 6 over 1, see that you can reduce the 6 and the 3, it'll leave you with 2 over 1 times z over 1, so 2z over 1 is 2z. But yeah, that gives me just 2z, which is nice. On the other side here, I've got 6 times z over 2, and in a similar way, 6 divided by 2 is 3, so this is going to leave me with 3z. Okay, now I've simplified this equation. I'm done with step 1. I'm ready to collect the variable terms on one side and the constants on the other. I see that I've got variables on both sides, and just this constant right here. So I guess I'll move my variables to the right-hand side. So to do that, I have minus 2z. Instead, I wish that was plus 2z, so I'll add 2z right there. According to the addition property of equality, I added 2z over there. To keep this equation equivalent, I need to add 2z over here. Great. 120 minus 2z plus 2z is just 120. 3z plus 2z is 5z. Okay, now I'm to that point where I have one thing equals another thing, right? Just one term on both sides of my equation. So I think that I can do my next step. Step number 3, multiply or divide both sides so the coefficient on the variable is 1. My coefficient is over here. I want to multiply or divide so that that was just a z. That is 5 times z. So I'm going to divide both sides by 5. So 5z, and I want to divide by 5. So, since I did that on this side, I have to do it on the other side. And double checking, yep, those are both 5s. Good. 120 divided by 5 is 24. Oops. 5 times z divided by 5 is z. The solution to that equation is 24. So I think that the solution to this equation is 24. How do I know? Well, I'll check. Let's see if I can. It's not buying it right now. So I've got this equation. I want to check z equals 24. So z is 24. This says 20 minus 24 thirds is equal to 24 halves. And now I know, is that true? Well, let's see. 24 thirds, 24 divided by 3, let's see, 3 goes in there 8 times. 24 halves, half of 24 is 12. And I can see that 20 minus 8 is equal to 12. So this is true. So 24, in fact, is my solution. There I go. There are the steps written out and used to solve a linear equation in one variable.